So Perlin noise is essentially the phenomenon of controlled randomness. You'll see right here we have this kind of snake-like movement going on, and if we look at the very beginning of the snake right here, you can never actually tell which direction it's going to go in. It's completely random, but at the same time it's controlled randomness. It's not like the beginning is transporting all the way to the left-hand side, to the right-hand side, up, down, every which way. If it were to do that, it would look something like this, just complete chaos. You never know where the beginning of each dot is going to go. So instead of doing something like this, we can get a really smooth, nice effect using Perlin noise, controlled randomness. So to get such an effect, it's really not that hard. All we need to do is understand how a Perlin noise function works, and once we understand that, we just add it into our typical canvas piece, and it's going to function something like this. There are a lot of unique opportunities to create something great here. So to start, what we're going to do is open up a typical HTML canvas boilerplate, and I'm actually going to cut out a bit of code here to make this as simple as possible. So I really just want to start with a blank canvas. We don't need any event listeners or anything like that. We can keep the object for now. Implementation, we're just going to go ahead and get rid of all of this for the time being. We really want to keep this as simple as possible. We don't want any fill text when we hover. We don't have an init function anymore. We'll get rid of that. So to really understand Perlin noise, we're going to start very small. It's always good to focus on the details before expanding onto something like creating a snake with multiple balls moving in random directions with Perlin noise. So we're just going to get one dot, one circle on the screen, and then we're going to be moving it ever so slightly with Perlin noise, and then we'll keep expanding from there until we get something that looks really cool, and you'll understand how to use Perlin noise within your own canvas pieces. So to get a circle or a dot on the screen, you'll see here I already have canvas set up and being pulled into JavaScript, and I have this default object in place. And this is from the HTML canvas boilerplate. You might have seen it from some previous episodes, but really all we're doing here is pulling in our canvas, setting its width and height to the width and height of the browser, and we just have this default object. So instead of creating a default object, we want to create a circle object, because that is what we're going to be getting on the middle of our canvas piece. We have a constructor, so whenever we create a circle, we have some default attributes that we are assigning to that specific circle we create. We are instantiating an object, instantiating a circle, which means we're creating different instances of the circle with its own unique properties. So our unique properties to each circle that we create is going to be an X, a Y, a radius, and a color property to start. We have a draw function that when called actually draws our circle. So when we call this, all we're doing is beginning a path, calling an arc function, which is technically just a circle function. We're filling it in with whatever color we specify within our constructor function. So if we specify our color should be blue, well, we're going to fill our circle in as blue. This fill here is just kind of a duo piece to the fill style. They go together in order to fill in circle, and then we're closing the path. Simple enough. We're just creating a circle with our draw function, and then update. All it does is call draw. Technically, we don't even need update just yet, but this is where we're going to put our code that actually animates our circle as we begin to develop our canvas piece. Now, we do have an animate function in place that is just calling itself over and over again with request animation frame. Whenever you see request animation frame, whatever function name is inside of this, it just means it's going to call itself over and over and over again as long as you call it in the first place, like you see down here. And then each time that we animate our canvas, we are clearing it. So if we don't clear our canvas, we're going to get circles that just kind of stay on the screen. And when we move them, well, it's just going to create like a line essentially of circles no matter which way it moves. So instead of creating that line, we are clearing the canvas. We're giving ourselves a clean slate to give ourselves the illusion of a circle actually moving without creating that draw. So to actually get this circle on the screen, we created a circle class. Now we need to actually create a circle. So to create a circle, we're just going to go right in between our class declaration and our animate function, and we are going to create a constant called circle. And by the way, a constant is just a variable that is never supposed to change down the road. We only want one circle. We know we're not going to change this into anything else at the moment, so a constant is a better choice than a variable, var, or let. So circle is going to be equal to a new circle, And we can use new here because we have this circle class. So we're going to be creating a new circle with a new set of properties. What kind of properties can we create for this circle? Well, if we look within our constructor function right here, we can see our properties are x, y, radius, and color, and they're being passed into this.x, this.y, etc. Those are the actual properties. So we know what we need to pass in whenever we are creating a new circle. So we need an x. And if we want our circle to be at the very middle of the screen, and our canvas right now, by the way, is taking up the full width and the full height of the screen, well, what is the x value going to be? Well, we want it 1/2 of the canvas width. And if we do that by typing in canvas width, you'll see right here we're assigning inner width to canvas width. Inner width is just a window property that takes up the full width of the screen. If we say we want our x value to be our canvas width, well, that's going to put our circle all the way on the far right hand side if we were to create it like this. But we want it right in the middle, so we're just going to divide this by 2. If we look at this right now, our canvas width is probably around like 500 pixels from left to right. And if we want it right in the center, well, just divide it by 2, 250 pixels. Simple enough. But now we have to do the same thing for our y value. So all we have to do is type canvas height, and that is assigned up here with inner height. Another window property that just gets the height of the browser. And then we're going to divide this by 2. So if this is 1,000 from top to bottom, divide it by 2, now we have 500. So let's just hypothetically say 250, 500 is going to be in the center. We now need to give our circle a radius. If we don't give it a radius, well, it's not going to exist because every circle needs a radius. I'm going to start off with just 10, and we'll see how that looks. We might want to make it bigger or smaller. It doesn't really matter. Then we need a color. I don't really know. I think blue is just the first one that comes to mind, so I'm going to go with blue. So right here, we created a new circle using our circle class. This is kind of like a... Ooh, sorry about that. My light fell off. It's shining on my face to brighten it up. Put it back in place on top of my monitor. Nice and secure. So we have this circle class. It's basically a circle blueprint. It says what all circles should look like as we create them. And we just created one, and we're storing it inside of circle. So if we console log out circle, open up our inspector, which we can do by right-clicking the browser and clicking inspect, and heading on over to our console. If we refresh the page and open up this object right here, you'll see this is what our circle consists of, our one circle object that we created using our circle blueprint. We have a color of blue, a radius of 10, an x of 320, and a y of 133.5. So if we're looking at this right now, our actual canvas width is going to be 640. We're just dividing in half, so that's why we get 320. And our actual canvas height is going to be 267, I believe that is. And that is the height of just this small view as we're looking at this within our console. So we know we have our circle, but why is it not showing on the screen? To get this to actually show on the screen, this is when we have to call our circle's draw function. So what we can do is we can try calling circle.draw outside of our animate loop, but you'll see if I do that and refresh the page, we're still not seeing anything. And that is because our animate function right here is overwriting our draw. If I go ahead and comment out animate, you're going to see our circle. But once I activate it again, it just disappears completely. Each time we call animate, remember, animate is just being called over and over and over again. Each time we call animate, we are clearing the entire canvas from the left to the right to the top to the bottom. So if we clear this whole thing, well, our circle is gone. As a result, we want to draw our circle after each time we clear our canvas. That way, even though we are calling our animate loop over and over and over again, well, we're also calling our circle draw function over again, which means it's always going to be drawn even if we start moving it from left and right, top down, wherever it is on our screen. So we can actually start adding in some animation here. Let's go ahead and just start moving this from the middle downwards. So if we want to start moving this downwards, what do we do? Well, technically we can just add in circle.y plus equal to 1. So all we're doing is adding 1 pixel onto our circle's y value. And this is totally valid. Let's go ahead and see what that looks like. So I save this, refresh the page, you'll see the circle is starting to move. And just to really hammer in what clear rect does just into your head, I'm going to go ahead and comment it out. So you'll see once I take out clear rect, we're no longer clearing the canvas and we're just drawing on top of it over and over again. And that's why we see this line here, and it can make for some really cool canvas creations. But for the most part, what we're wanting to do right now, it's probably safe to keep it in. So we're going to keep clear rect in there. We're just going to have our circle going downwards because we're adding 1 pixel onto its Y value. Now, how do we get randomness added onto this motion? Well, that is where Perlin Noise is going to come in. So what does a Perlin Noise function even look like? What am I talking about? Well, essentially Perlin Noise is just a function that returns a value 0 to 1. Sounds familiar? It's almost something like math.sine, math.cosine, math.tangent. It's just like that, but it returns a value in a specific sequence. So in order to begin making use of Perlin Noise, you have to find a Perlin Noise function. And it is quite complex. It's something that I would not be able to write on my own. People have written this previously because it is so complex, and it just ends up working. So if there's an implementation in place, why not just go ahead and use it? Now, personally, I have gone through many implementations and I've tried to find one that just fits exactly what I need. Something that's just easy for me to understand. And when it comes to Perlin Noise for JavaScript, I just really had a hard time finding something that actually makes sense. You'll see if I full screen this and head into like a gist, something along the lines of that. We have a function here for Perlin, and this just right off the bat looks confusing to me. I don't really know how to use it. There's no documentation. If I look on GitHub, it looks like we have another noise function, and this would probably work, honestly. I believe I did use this one before creating this video, and it returns a couple of noise functions in which we can use to create that controlled randomness. Nevertheless, I just ended up not liking their API. I couldn't really import this using modules, which is kind of like the newer way nowadays, modern way to import libraries into your project. So what I ended up doing was I ended up creating my own Perlin Noise library based off of P5.js's Perlin Noise implementation. I don't even know if any of that makes sense, but what we're going to do to start making use of a Perlin Noise function is we're going to type in npm Chris courses / noise. And here it is. It's going to be the first result. This is the one you want to use, Chris courses / Perlin - noise. And this is just a really easy to use Perlin Noise implementation derived from P5.js. So to begin making use of this, you're going to want to have a package manager installed. And if you're unfamiliar with package managers, just do a quick YouTube search on how to use something like npm or yarn. I have a video on that if you'd like to check it out. But it's essentially you know how to use a package manager to begin importing libraries into your project, because it's just going to make your code so much cleaner compared to just importing things with a CDN and a script tag. So if you'd like to install this function, you can use npm or yarn. Personally, I always use yarn. So what I'm going to do is I'm going to open up my terminal, wherever that may be, and here it is, running the canvas boilerplate right now. That gives me that auto reload, and you'll see I'm inside of my project directory, Perlin - noise. So once I'm inside of my project directory, I'm just going to run this command, yarn add Chris courses / Perlin - noise. Now with yarn, you need to make sure that you have yarn installed. If you don't have yarn installed, just run npm install. It's going to do the same thing. Yarn is just a little different. It's a little faster, and it's a little less messy when running the actual command. If npm does not work for you, make sure you download Node.js from nodejs.org, and npm is going to come installed right after you install Node. They come bundled together. So go ahead and make sure that you download Node, and then you'll be able to run this npm install command. Now you'll see here I wrote a little bit of documentation on how to use this Perlin Noise function. So first thing we're going to do is just import in our noise function, and then all we have to do is call it with one argument. Now what is this argument? It's any value. It does not matter what number you put inside of this noise function. No matter what it is, it's always going to return a value 0 through 1. And that value 0 through 1 is what we're going to use to begin controlling the motion of our circle, whether it be left, right, up, or down. That motion is always going to be dependent on this noise function return value. So I tried to basically lay out this documentation in the ways you would use it. And this right here is basically going to be how we really are going to use it at some point in time as we begin animating stuff. Well, let's take it piece by piece, and we will get to exactly that rainbow snake kind of creation that I made earlier. So in order to use this noise function, we have to import it. And since we installed it with yarn, we can go ahead and copy the first line and then head back to Sublime Text, not that file. And at the very top of our file, this is where you typically import packages and such. We're just going to paste in that first line where we are requiring this noise function. So if we save this, and as long as we imported as long as we installed our actual Perlin Noise function, well, we're going to be able to make use of this noise function within our code. And we can test this by console logging out noise, checking out our console over here, and you'll see we have this really complex function in place. And this is what it actually looks like. I did not write this. I do not want to write this. But someone really, really smart who's good with math and understands noise in general wrote this function to be used in JavaScript as an implementation. So now people like us can go ahead in there and just create something that looks really cool as a result. So we have our function as noted by console log noise. Now we can begin using it within our actual code. So I can't stress enough this noise function. It takes any value, any number at least, and it's always going to return a value 0 through 1. So the first thing I'm going to do is add in noise 1 here. We're going to see what exactly that looks like. You'll see it looks exactly the same as we had before. If we go ahead and console log this out, so we always want to console log out our values to see what we're getting. We're getting the same value over and over and over again. So we're getting the same value over and over again, and it's just 0.31. If I refresh the page, we get a new value. We get a new value each time I refresh, but it's always the same as we begin calling this over and over and over again. So what I want to stress here is when this noise function is being pulled in and when it is generating values, the noise function basically comes pre-populated with a huge array of values. And within this array of values, those are going to be all the values that are random but somewhat related to each other. Now, this might be a little confusing, so I'm actually going to take it over to the whiteboard over here. So here you'll see we have a canvas just drawn onto the whiteboard. It's not even going to really use the canvas, so it's not like it really matters. But I want you to understand exactly how noise generates values. So when it's actually brought in and we call this noise function, it generates a huge array of random numbers 0 through 1. So it could be really anything, and let's make this a little realistic so you understand better. So it could be 0.35. Another one could be 0.4 because this is random, but at the same time, it's also somewhat related to the previous value. So the next value would be something like 0.38. Another random number, but still somewhat related to the previous value. The numbers that are generated within this array are in sequence, and as it goes on and on, you're going to get a random number each time, but it's always going to be related to the previous value in some way. So, for instance, as we begin to get our numbers from this noise function, and this noise function basically is this whole populated array right here, as we begin to call things, let's go ahead and say we want to call noise, and this is just going to be 0. If we call noise 0, well, we're going to get this value right here. If we go ahead and call noise 1, well, we're going to get this value right here. Same thing if we were to call noise 2, we would get the third value in the array. So as we begin calling different numbers within this noise function, we are basically just going through this array. And since each value is related to the previous one in some way, we get something that's random, but at the same time, it's always going to be related to the previous value in some sort of manner. So let's just look at this. And we're going to head back to the code over here. So since we're calling 1, we're getting the first value in that big noise array. If we call 0, well, we're actually now getting the first value since we're calling 0. So let's go ahead and console log out 0, and we'll also console log out 1. You'll see we're only getting 2 values repeated over and over and over again. It's 63933 and 702. Those numbers are pretty close together. At the same time, they're randomly generated because the randomness is based off the previous value. So what we can do here to begin adding that noise and actual movement is we can start traversing through this noise function and adding in different values over time. So rather than just adding in 0 every loop we go through in this animate loop, we're going to add in 0, and then we're going to add in 0.01, and then we're going to add in 0.02. This number is just going to keep increasing over time, and as it keeps increasing, we're going to get a different level of randomness on our y coordinate. So to get something that keeps increasing over time, we want to create a variable outside of our animate function, and this is actually going to be a let. A let is something that you can actually change, unlike a constant. So our let is going to be, let's just say timer is equal to 0. Actually, let's just go ahead and call this time, just to be extra specific with our code. Time is going to be equal to 0, and as we go through our animate loop, time increases. We're going to say time increases by 0.01 seconds. I don't really know the value, but it doesn't really matter. So time is going to increase by 0.01 as our animate loop goes. We can console log this out. Now we see our time is actually increasing, and we can utilize this time within our noise function. And as this time increases within our noise function, we're going to be returned a new random value based off of the previous random value. So to relate it in some way, it's controlled randomness. It's not just completely random like using a math.random function. So we hit save now. You'll see we're going down, we're going down, we're going down. It's great, but it's going down at different rates if you look really closely. Let's go ahead and refresh that. You'll see it gets really fast, stops, begins, and it keeps going. So we have noise in place, but then again, it's not really moving back up like we might want it to. So to understand why this is happening, let's go ahead and console log out, circle.y, and you'll see our y value just keeps increasing because no matter what our noise value is, even though it's always going to be something 0 through 1, we just keep adding it on to circle.y over and over again. So if we keep adding it on there, well, eventually it's just going to go off the screen. It's not really what we want. So instead of just adding something on there, we can set it equal to. And now, since it's always something 0 through 1, it's just kind of stuck at the top. We want to make sure that we get the full range of values within our canvas. So 0 through our canvas's height. So to get some sort of value from there, what we can do is we can take our noise function that's using time as its argument and multiply it by canvas height. And since we're multiplying 0 through 1 by our canvas's height, it's always going to return some sort of value in there. And since we're increasing our noise value over time, it's controlled randomness. It's just up or down in some sort of way, but always related to the previous value. So we're not just getting with randomness. We're just getting this nice, smooth, controlled randomness instead. And this is honestly pretty fast. So if we want to slow this down, we can traverse through our noise array a little slower just by decreasing the amount of time we're adding on each animation loop. So instead of 0.01, if I do 0.001, you'll see it moves a little slower. This is kind of too slow for me. Don't really like that. So 0.05 is a little better. So now we get that nice controlled randomness that's super, super smooth as well. So this is only happening for the y-axis. It really starts looking a lot cooler once we begin editing the x-axis as well. So all we need to do that is copy circle.y is equal to noise time times canvas height. And then we're going to paste it right above. Change circle y to circle x. And we can save this. It's still going to look pretty cool. I guess not that cool. It's just kind of going in a diagonal motion. And that's because we're still multiplying our canvas x by height. We want our x value to be anywhere from the left to the right hand side of the canvas. So instead, we're going to multiply 0 through 1 by our canvas's width. And that'll give us any value within our canvas's left and right hand side. So you'll see even though we just change height to width, we're still getting that kind of same diagonal movement. And this is because when we're calling noise time in two places in both x and y, well, noise is still going to return the same exact value for both our x and our y coordinates. And even though we are adding them onto, we're multiplying them by different values with width and height, at the same time, these being the same every time is just going to give us that diagonal back and forth motion. So what we need to do is we need to provide a little bit of offset between our x and our y values, and that is going to get us far enough distance within our noise array to make sure that our values are completely apart and we get that nice little look of everything just moving completely randomly. So to do this, it's really simple. All we have to do is add on some sort of value, probably bigger than 1, within our noise function. And that's just going to transport us to a different spot within our noise array. And since we do that, well, we're using different previous values compared to the previous values within this noise function right here. And since those values are so different from each other, it gives the appearance, the illusion of everything being completely random. So now you'll see we're getting that exact random effect that we want with our one circle here. So ways we can make this look cool is we can go ahead and comment out our clear rect. And now it's going to be drawing across our entire screen. Like I said, you want to make stuff look cool, you just go ahead and take out the clear rect and now you're good to go. But we're not going to end with this. I would never end with this, at least for my boys on YouTube and girls. So we're not going to end with this. We're actually going to create multiple circles and get them all moving at the same time. So to get multiple circles on the screen and get some sort of similar effect to this is a very, very common procedure. So what we want to do is create a grouping of circles rather than just one. So we created one new circle right here, and to create a grouping of circles, we're always going to create an array. So what we can do is create an array called circles because it contains multiple circles. And we're just going to set it to an empty array. Now this is empty, but we have to populate it with circles. So to populate this with circles, what we can do is use a for loop. All we're going to do is type for, let I equal to 0. That is just where we're starting off in this for loop. As long as I is less than, let's say 100, then we're going to call this 100 times. All this says is just call the following code inside of this 100 times. That's really all you need to know. So we have our circle array, and each iteration of this loop, we're going to populate our array right here with a new circle. So we can go ahead and copy this new circle code and put it inside of our push function right here. Make this a little bigger, a little easier to read. So push just means add into the array. So we're adding 100 circles into this array whenever we call this loop, and we can console log this out. Console log out circles. Make sure that we have things working. So we have an error circle.push is not a function, and that is because right now when we're calling circle, we're referencing our initial circle right here. We can go ahead and get rid of this initial circle. We're just going to go ahead and delete this and refactor as we go. And if we delete that, well, we need to make sure that we're calling circles.push instead of circle.push, because push is a function that is only there for arrays. And our original circle was an object, not an array. So once we save this and refresh over here, well, if we look at the very top, you'll see we now have an array full of 100 circles. They all have the same value, which we're going to fix, but now we have all these nasty, nasty bugs at the bottom. So what we're going to do to get rid of these is we're simply going to comment out any code within our animate loop that has circle, because remember, we just deleted circle up at the top. Now we can't use it. So when we save with our commented code, now we have what we want, an array full of 100 circles. Now remember, when I actually looked inside of these, they all have the same value. Not really what do we want. I'm not even sure it really matters though. So let's just go ahead and start with these 100 circles in the same place to start. We know they're all there in our array. And now for each circle in the array, we want to draw it and make sure that we're editing its X and Y values individually with this noise function to get that really nice controlled random look. So to access all of the circles within our array, we're going to reference our original array, which is our circles array, and say for each circle, and this is just a nice little arrow function right here, shorthand for function, and circle would be the argument. So what we have here is shorthand for this, just in case you're new to ES6 and JavaScript. So for each circle within our array, we're going to call circle draw. So all of our circles, all 100 of them, are going to be drawn on top of each other with just this. If we save it, you'll see those are 100 circles. Without a doubt. Look at that anti-aliasing. So we're drawing all of our circles. Now we want to edit all of their X and Y values. So if we go ahead and uncomment this out and paste it right beneath our draw function, well, now our 100 circles are all moving together. And it creates for like this really pixelated orb kind of effect. Not really what we want though. We want to kind of create that Snakey kind of vibe. Now to create the snaky vibe, as I just called it, we need to edit the offset. Basically, we need to make sure that each circle within this array, 0 through 100, is at a different point in time from the last one. Basically, its noise value needs to be different from the last one. So to do this, what we're going to do is we're going to add a property into our circle constructor called offset. It's kind of like time offset, like how far apart should this circle be relative to the last one. And whenever we add a new argument within a constructor function, we need to create a new property. So I'm just going to copy our color property and say offset should be equal to this offset, whatever offset we pass through. So now that we added this new constructor function, we need to add in a new value for offset. So our value for offset is going to be something different from the last value. And if we look at our for loop, each time we go through our for loop, I is always going to be different on each iteration. First iteration, I is going to be 0. Second iteration, we're adding 1 onto I, it's going to be 1. Third iteration, add another 1 onto I, it's going to be 3. So we know I is always going to be different. And it makes for a perfect candidate for our offset value. So now, if we go ahead and console log out circles and open these up, we have an offset value for our first circle at 0. Our second offset is going to be 1. Our third offset is going to be 2. So we're starting to get that offset that we're looking for. Every offset value is different from the last. So now what we can do is utilize these offset values, because within our circles array, we're looping through each one. And if we loop through each one, we can access each individual property, including offset. So if we take, instead of plus 20, if we take our circle's offset and add it onto our time right here instead, hit submit, well, we're starting to get some really interesting, cool effects going on. Let's go ahead and do the same thing for our Y value just to see what that looks like. Make sure you add on that value. We're kind of back to going both diagonally all over the place. So what we're going to do is we're actually going to keep our 20 in there to give our X value something completely different from our Y. And now we have this really cool kind of, I don't know, like galaxy particle mesh effect. I don't even know what to call this thing. It's starting to look really cool. Like, honestly, I could probably end it at this, be like, oh, cool, we're good to go. But it's good stuff. Let's go ahead and see what it looks like without clear rect, because, you know, that's where the cool stuff comes. All right, it's looking pretty nice. Or is it? We can't even tell what's going on now. So let's just go ahead and revert that. So right now, the reason everything is just kind of galaxy-like and really all over the place is because our circle offsets are so far apart. So what we can do here is, instead of an offset of 1, a difference of 1, so instead of I being 1, 2, 3, 4, 5, 6, 7, 8, we can multiply this by a fraction. So 0.01, and you'll see we start creating that snake draw-like function. And now this would make a lot more sense to get rid of our clear rect function, just so we can see this thing being drawn across our entire canvas. Maybe not, it doesn't look as cool as I thought. So if that's the case, just Command Z, save, and you're good to go. So we're kind of getting closer and closer to this guy right here, but you'll see this still looks way cooler than just this. And we kind of have to do a little bit of coloring and a little bit of effects, a little bit of special effects to get this working correctly. So the first thing I pretty much always do to make a canvas piece look cooler than it is instead of using clear rect, I always like using fill rect instead. And what that's going to do is, instead of just making a completely white background, getting rid of everything, each animation frame, it's going to color that background in. So you'll see right now we're filling it in as blue, the same color as our circles, so we're not actually seeing anything. But instead, we can go ahead and change our fill style to something else, an RGBA value. And if we do this to 0, 0, 0 with 1 for our alpha, and it looks like I just forgot to add an equal sign there, you'll see we have a black background that's already looking a lot better because of that contrast it provides with the blue. But if I want to really make this more interesting, I can go ahead and edit this alpha value, and that's going to give that fade effect that you saw within the canvas piece. You'll see everything eventually fades at some point in time. Well, that is because of this alpha value right here. So if we change this to 0.01 0, 1 instead of just 1, well, now we are getting that kind of fade effect because the background is just being layered on top of each other at a different opacity than just pure 1. And as it just begins layering on top of the old canvas drawing, it adds that fade effect. So we have our fade effect, but we don't really have any rainbow swirl or any like difference between our different dots. This looks like one giant line, but in reality, it's just a bunch of different dots composed together, and they're all following the same Perlin Noise array, so they're all following the same line and pathing. So to get our color to be different for each circle, instead of creating each circle with the color of blue, we're going to create these using an HSL value. That stands for hue, saturation, lightness. So the hue value is going to be any number 0 through 255. 255 is the RGB special. And oops, I don't know how that light just turned on me. Like, I swear it just turned on its own. I'm watching the video to see it. So hue is just going to be any number 0 from 200 to 55. And that's going to control what hue, or like what actual color are we putting within this circle. So if we start with just say, like, let's say 100, we'll see exactly what that looks like. But first we need to insert the saturation and lightness values. Saturation and lightness are values anywhere from 0 to 100%. It controls how strong the color is or how faded the color is, saturation that is, and lightness controls how bright or how dim the color is. So typically I just go with 50%, 50%, meet it halfway within hue, saturation, lightness. Let's see exactly what this looks like. So we have a pretty bright color with our hue and our saturation and lightness being 50%, and our hue value is at 100. So if we change our hue value to something else like 200, we're getting a different color. And I might be completely wrong on this. Hue might actually be 360. I can never remember. I remember people were calling me out in my last video. It's like, hue goes to 360. I don't really remember, honestly. It looks like it does go to 360 because when I put something in there, it actually worked. Just go ahead and leave a comment. I'm not really sure. It's either 255 or 360. I'm going to say 360 works. Maybe not. I don't know. I'm just going to go with 255 to be safe. So hue controls the color, and then saturation controls how deep that color is. So if I turn it up to 100, now we have this really, really deep purple blue color. And it doesn't matter what I change my hue to, it's always going to be super deep as a result. If I want it faded, turn it down to like 10%. Now we have this faded color. I like bright colors. I don't know why. I'm like a fish in water going after lure, but since I like bright colors, I'm going to keep this at 100. Now we want a different color for each circle within our array. So we need to start adding some sort of randomization, mainly to our hue value, because that is going to control the actual color. What we can do is, instead of just using 100, we can use math.random, which always returns a random value 0 through 1, just completely randomized, and multiply it by 255. If we do this, well, we're always going to get some sort of random value 0 through 255. So if we save this, we're not going to get anything that looks great. We're just getting this black, nothing actually random. And that is because whenever we use some sort of variable in a string like this, we need to make sure we're using, I believe it's called a template literal in JavaScript. So if I replace my quotations with a backtick like so, it's still going to be a string. But the cool thing is, within these backticks, we can add a $, opening curly bracket, and then add a ending curly bracket to wherever we want our equation to end. And whatever is inside of this $ bracket is going to be equated. It's going to be computed by JavaScript. So if we save this and refresh the page, now we have that big rainbow snake-like thing that we were going for. And man, this turned out a lot different than I remember it being. I can't even tell if I really like it, to be honest, but it looks pretty nice to me. So I'm going to go ahead and refresh so we can see what this looks like. Looks like we're getting this little dot in the middle of the screen, and that's because we are drawing here once and then we're transporting our actual value to wherever we say within our animate loop. So to alleviate this, what we can do is we can basically set the initial X and Y to something that actually takes noise into account. It's probably like too much work for me, honestly. So instead, I'm just going to kind of janky rig it. And instead of just choosing something right in the center, I'm going to set our initial value to -30, so it's off the screen. And I'm going to do the same thing for height. It doesn't matter what we set these X and Y values to initially, because when we're calling this animate loop, we're resetting the X and Y values based on noise and time functions. So if we save this, everything starts off on the screen, but once we start calling our animate loop, we are directed to our X and Y noise values instead, and that's going to start it wherever that is, and it begins the whole kind of loop snake process through our array. So that is going to be it for this one. I would love to see what you guys got, so be sure to post your creations on CodePen. Just send them over to me in a comment on the video. I'll make sure to check it out. And yeah, you guys always come up with some super cool stuff, probably cooler than what I just did here. So if I were to recommend how to start taking this next level, definitely play with the randomness values within your colors, within your radius. If I begin starting to change the radius here to something 100, you're going to get some really cool effects, some crazy stuff. You can even randomize this. You can do so much cool stuff just so quickly by playing with random. And now you have a new technique within your disposal of noise function. So instead of math.random, try using noise instead to get something a little more controlled. You'll see here, I'm just changing the actual radius of each of these guys. If it's a little more apparent if I go down and only loop through this 20 times. Just really, really interesting things that you can do here just by playing with the randomness, the colors of everything. If I go ahead and change my fill style, you'll see with a white background, we get a different fade effect compared to before. Just all this cool stuff you can do. So be sure to go ahead and check this out. And oh, and yeah, I almost forgot. If you guys would like to check out more Canvas tutorials and also web app tutorials, make sure to check out chriscourses.com. I basically developed this whole learning education platform in which I provide both free and also premium tutorials to help you become a better developer. I cannot recommend enough the web application for beginners course, because it teaches you how to make a web app in which you can log in, sign up exactly like I created for chriscourses.com. Everything that I use to create chriscourses.com is within this course. It teaches you how to create the app, how to launch the app, how to log in, log out. Everything you need to know is within this one course. There is some price with it, $15 a month, $99 a year. Just be totally transparent with you. But I'm trying to make this a full-time thing, so I got to charge something in order to help pay the bills, or else I'm going to be doing client work forever. I also have a few courses on Canvas, such as image manipulation. You can see here. Oh man, I hate watching this video. I don't know why. But I show you guys how to create cool Canvas things like this, where you have some sort of image and you're going to be reacting to the image using Canvas. So lots of cool things here. I'm continually adding videos to this. And yeah, I know this is like kind of like a plug, but would love to be able to do this more often. So no other way to tell you guys about it than to tell you guys about it. So that's it. I'm done.